Okay, we just got done watching the hot air balloon, right? What happened when we put the hot air balloon over the flame? Rick?
It went up.
It went up. What caused the hot air balloon to go up? Kylie?
Air, hot air.
Hot air. We know that hot air rises, right?
Yeah.
Okay. What made it though? What caused it to float? We know that hot air rises, so that possibly could be. What else could have caused it to float?
The steam, the particles inside the steam are making the hot air balloon go up.
Okay, so those particles are moving around super fast, that's causing it to shoot up and move different places. What do you think, Lucas?
The force of the hot air, it can't get through the balloon, so it starts to push it up with the air balloon with it.
Okay, good. Well, we will find out what will happen, or what actually did happen, what caused that air balloon, or the hot air balloon to rise at the end of today's lesson. But it has something to do with density. Does anybody know what density is? Seth, do you know what density is?
Density is,
How about we think pair share? How about you guys get together in your groups and I'll give you 30 seconds and you think of how would you describe density?
density is
How would you guys describe density? Which means what? How are the particles So you think the hot air balloon, you think it's more dense or less dense? Less dense, so it's what it's less. So dense means that. Right? Clap your hands once and remember. Clap your hands. Okay. Over here in this group, we talked about density, and they didn't have the exact definition for it, but Hayden said if something's dense, it's what? It's heavy. What makes things heavy? Why would it be heavy?
Gravity.
Gravity, but what does all matter have to have? What does it have to have? Mass. So the more mass an object has, the more dense it's going to be. I have a short video we're going to watch. The short video is going to touch again on what is matter, how to measure the mass of an object, how to measure the volume of an object, and then we'll use those two ideas to figure out density, because density of an object is mass divided by volume. Okay, so I need your eyes and ears on the board. Now this is just a part of the video.
Out the Matter Analyzer.
What's that?
It's a tool. It helps us to measure the properties of matter.
Hey, my mom uses a tape measure like this to see how tall I am. Is that what you mean by tool?
When I go to the doctor, I stand on a scale to see how heavy I am.
When I didn't feel good at school, the office people checked my temperature with a thermometer.
Ah, yes. Well, some of these tools might be found in your own homes. Some tools help us to see matter better, like microscopes and telescopes. Some tools help us to measure matter. This is a balance scale. A balance scale helps us measure how much matter is in an object. I'm going to put a carrot on one side of the scale, and I'm going to put a kiwi on the other side. Which object do you think has more matter in it? I'll give you a hint. One side of the scale is going to go down further than the other one.
That's too easy. The kiwi, of course.
You're right. That was too easy. Now, let's measure the amount of matter that's in that kiwi. With the kiwi on one side of the scale, I'm going to put blocks on the other side. And we're going to stop adding blocks when both sides are about the same. Ready?
1, 2, 3, 4, 5, 6, 7, 8, 9.
The kiwi has as much matter as 9 cubes. Therefore, we can say that this side of the scale has as much matter on it as this side.
But why does it matter?
You'll see why.
Okay, so they showed a tool called a what?
A scale.
A scale, a balance scale, right? And the balance scale helps us measure what physical property of matter. How much mass it has, right? And so in your groups, I want you to describe how you're going to use your scale to figure out the mass of your crayon, your tongue depressor, or craft stick if you want to call it that, and your pasta noodle. Okay? I'll give you 30 seconds. Talk in your group. How are you going to figure out the mass of those objects? And how are you going to know what weight it is, what mass it is? Clap your hands once for me, please. Clap your hands twice. Okay, Brenna, what was one of the key things that you're going to know how much mass is in your matter?
To put it on a balance scale.
Put it on the balance scale, then how are you going to know how much mass is in it?
Put grams or blocks on it.
Put grams or blocks, something that's the same, right? And then how are you going to know how much exactly it is when the scale is what?
Equal.
This, or even?
When it's not when it's
When it's even, right?
yeah.
Okay, perfect, good. All right, now let's look at another video on volume.
Now look around this kitchen. Everything is taking up space. This refrigerator, the hot plate, the popcorn, the sink, these chairs, you on them.
All of this is matter, and all of it is taking up space.
So, we've seen that matter has many different properties. It can be alike and different, but it always has mass and takes up space.
Okay, that didn't show what I thought it was going to show. Must have clicked the wrong one. But let's talk about, we read about 2 days ago in our science thing, how to find the volume of an object that wasn't square or rectangular shape. Who remembers how to find the volume? Brenna.
So if it was like a circle, you would.
Like that marble. How did Mrs. O show you the volume of the marble?
Oh, you put like water up to let's say 35, and you pop the marble in and it went to 40.
Okay, so then how much volume does the marble have? If it went from 35 to 40. The marble went 5. You would take the difference of how the water has changed. Okay, are there any questions about how to calculate mass, how to calculate volume?
No.
Okay, in today's lab, you are going to explore density. Density is mass divided by volume. So if you figure out how much matter is in your object and you divide it by how much space it takes up, then you can calculate how dense the object is. Now, over there in one of those groups, we talked about density being heavy, right? The particles that are dense are really, really packed tightly together. When particles are spread out a little bit more, it's less dense. And so objects have the property of buoyancy, right? What's buoyancy? We talked about that last chapter. What's buoyancy? The ability to float. And so all matter has that property of density and has that property of buoyancy. But when an object's more dense than another object and you're putting them together, what's going to happen to the more dense object? It's going to, yeah, Avery, what are you doing? It's going down. It's going to sink. And the object with less density is going to float. Okay, you are going to be given 3 different types of liquids. You are going to be given water, you're going to be given syrup, and you are going to be given vegetable oil. On your lab worksheet, I'd like you to predict which liquid is going to be more dense and which liquid is going to be less dense. And while you're doing that, I'm going to go get your liquids for you. Your prediction. You guys need to write it down on line number 1 with your prediction.
Like oil. Have you ever seen oil and water? Which one? Like oil and water. Which I do vegetable oil. No.
Okay, clap your hands once for my voice. Clap your hands twice. Okay, does everybody have their predictions recorded? Your predictions need to be recorded on line number 1. If you haven't done that already, go ahead and please do that.
Get on your speaker. Water, oil, and syrup. Different densities. What it's not going to make sense. But no, it would something would be on top. They would layer.
Rick, do we need one more?
Yeah, it becomes slowly floating up. Slow. That means
All right, clap your hands once. Clap your hands twice. All right, in your group, you need to read through your lesson. Remember, we're changing it up where it says 100 milliliters. How many are we going to put in it?
50.
50. So you could scratch that off and put 50. You're doing 50 of syrup, 50 of vegetable oil, and 50 of water. Okay, when you need to go do the water, please go have one person go over at a time to the water fountain and just get your 50 milliliters water. But before you start, what do we always need to do? Read through our what? Instructions all the way through, okay? Please go ahead and start.
Make sure you put 50 milliliters water into Wait.
Okay.
I got a question. Which one do we put in? Water.
I would probably start with your water first.
In this?
Yep.
Yeah.
Or you could use your... Okay, Brenna, which one did you think was going to be the most dense?
Probably the syrup.
The syrup?
No.
The vegetable oil? Okay, why do you think the vegetable oil is going to be the most dense?
Because it's not like the syrup where it's very stiff.
Okay, remember when I explained what density is how tight the particles are, right?
That's how tight.
And how do you know the particles are tight in that one?
Because it's very, very hard to remove. It doesn't move fast like the vegetable oil does.
Okay.
Is this so size? Okay.
The right side.
Okay. So
Yep. Xander, what do you think?
water Because
You think the water's going to be the most dense?
since it moves around the fastest, and it kind of, if you put it into a glass, if you put like water in one glass and oil in the other one,
Uh-huh.
the water will be heavier.
The water's going to be heavier? Okay. So, because it's going to be heavier, then it'll be more dense. Okay. So, how are you going to be able to tell when you mix them all together? The most dense one's going to be located where in your jar? Is it going to be on the top or the bottom?
The bottom.
Okay, good. Miss Mia, what is happening here? What two liquids have you guys poured in there?
Water and oil.
Water and oil. And what can you see happening?
That the water has
The water has what?
more density because
That-
it's going to than the oil.
Okay, so the water has more density because it's below the oil. Okay, before Hayden pours that syrup in, Keelan, what's your prediction? What's going to happen?
That's just going to sit on top.
It's going to sit on top of the oil?
Probably. Or mixing.
Or okay,
It might mix in.
when you guys made your predictions, which one did you think was the most dense?
I thought that the syrup was most
You thought the syrup was? Okay, and why did you pick the syrup?
because it seemed more heavier than everything else.
Okay, it felt heavier than everything else. Okay, Keelan, what did you pick to be the most dense?
Oil.
Oil. Okay, and why did you pick oil? Just a second, Hayden, just a second.
Just really
Okay, and so you think the more liquid it'll sink more?
sinking.
So you think the oil is the least dense then, right? Okay. All right, Hayden, let's pour it in and see if you guys' prediction was correct.
Yes.
Ooh, what is happening, Hayden?
The syrup is sinking to the bottom because it's the most dense.
Okay.
And which were almost correct. If we changed the oil and the water around, we would have been
Okay, so you thought the water was more dense than the oil? Or it is, right? You thought the oil was more dense than the water? Okay. I want you guys to just write down your results, okay, which is in number 3, right, step number 3, and then kind of observe and watch how it changes. Mm-hmm. Yes, you can start.
So, do you dump that in there? Or in that?
The oil? Yes. I would measure it.
Yeah. To how much? Oh, that is messed up.
What happened? Seth, what happened?
The oil went to the top and the water went to the bottom.
Did you guys think that would happen?
No. They weren't mixed.
They won't mix? Okay, but the prediction says what will happen if you pour them together? Like, which one's going to be more dense? Which one's going to be less dense?
Well, the most dense is probably going to be the oil. The least dense is going to be the syrup. And kind of in the middle would be the water.
Okay, now, dense again, when we talked about Hayden, he said is the most what?
This would be
Why?
the back one.
Because it's the thickest. It has the particles you think closer together. Okay, how can we tell that the particles are closer together in that without having a microscope or anything? Yes?
Now Seth is supposed to rise above.
Okay, thanks.
Misso, do I put this in there?
Follow your lab. Follow your lab worksheet, Rick.
If you go like this, it doesn't move as quick.
Okay, and so it has still the properties of a liquid because it takes the shape of this container, but it doesn't pour as easily as some liquids. Okay. All right.
Yes, pour it in.
Pour it in and see what happens. Record your steps in 3. Do you have your 50?
Yeah.
You're okay. We'll clean up the mess later.
It's floating too. It's sinking to the bottom. It's sinking to the bottom.
Okay.
Yes, it will.
like a lava lamp yet. Caroline, do you have a lava lamp? Or have you seen a lava lamp before? Okay, how do you think they work?
Because something is denser than the other thing. And it tries to connect itself to like maybe there's some here and some down here. And it tries to connect itself and then it just moves weird. Like it works.
Okay, and so like the objects that are more dense do what? They sink, yep, they do. Okay, good job. What happened?
Vegetable oil and vegetable.
Okay.